Here they said, can two non-zero vectors that are perpendicular to each other in different planes be added together so their sum is 0? Yes, by using the equilibrium. Let me give an example. Here's a force, here's another one like that. Let's call this one F1. Let's call this one F2. I'm talking about, can we keep them in equilibrium? So I will come back to answer that question. So this one, the red one, will be their resultant. But then, if I were to put the other one, the blue, will cancel and keep them in equilibrium. Okay? Now, watch now. Let's answer the question. Can two non-zero vectors that are perpendicular to each other in different plane, one is on the y-axis, the other one on the x-axis, be added together so their sum is 0? The answer is no. It's no, because as long you have two vectors, there will be a resultant. They cannot cancel one another. We good, ne? Because resultant will never be equals to 0. They're in different planes. Alright, that's the answer for the first one. Let's go for the other one. The other one, which is this one here. The question is, under what circumstances would a vector have components that are equal in magnitude? Is this question, I mentioned it last time, where I said a vector with equal magnitude. I remember mentioning it. The one of the 45. Which one was that? Yeah, the one of 45. It was this one. Can you see? It was 45. A vector acting at an angle of 45. Under what condition? So it has to be a vector, I would say, acting at an angle of 45 degrees with either the x-axis or the y-axis. That's it. It must have an angle of 45. That's all. Done. And it's because sine of 45 will be equals to cos of 45. They're all equals to 7,707 or 1 over root 2 or root 2 all over the 2. They're exactly the same. That's why.